Hi everyone, welcome back, grade 11 learners. Today we are gonna answer electromagnetism questions. We have one multiple choice and one long question. So let's start. What I'm asking from you, please try first, get your answer and write your exam pad. After that, you are gonna see correct answer and then we'll try to explain. I hope it will help for your exams. All right. 20 seconds, I know not enough, just to stop the video and then get answer. All right, initially, I'm not reading questions, just like exam. Please read questions, try, get your answer first, and then we can carry on together. Good luck. All right, time is over. So we are gonna continue. We will answer this question together. These are multiple choice question. And then let's see our answer first. Our answer is B. Why B? Let's explain. First of all, this question coming from Lenz's law. What was the Lenz law? If you have a solenoid and solenoid, yeah, solenoid. If you have a solenoid and then a magnet is coming closer, if it is coming closer, we have same polarity. If you have here N, if it is coming closer, it's approach because they said it's approaching. If it is coming closer, A also same polarity N N. All right, we should remember this rule. If it is coming closer, they repel each other and then they have same polarity. But if it is going away, what's going on? If it is going away, you have opposite polarity. A will be S and then B will be N. But now for this question, they said this one magnet is coming closer. Approach to your what's that? Solenoid. All right. So coming closer, A is N and then B is S. First of all, we have this polarity for A and for B. After that, what we know inside the magnet, this is a magnet now. So inside magnet, magnetic fields moving from S to N. All right. Because of that, direction of magnetic field in solenoid B to A. So option A is gone, and then option C is gone because for direction B to A. What else we know? Polarity of A is N. Okay, polarity of A will be N. If they said south, it's gone, and then south is gone. Check. Polarity of A is north, and then direction of magnetic field B to A. Because of that, our answer is B. I hope it is clear. First of all, we should remember if it is coming closer, a magnet is coming closer, you have same polarity. And then they repel each other. And then if it is going away, they have opposite polarity and they attract each other. We should remember these two important points. After that, another important point for a magnet, directional magnetic field inside S to N, and then outside N to S. All right. I hope everything is clear. So if you remember these two, just total four important points for magnet, and then everything will be easy for this kind of questions. All right, for this kind of questions, everything will be okay. All right, let's continue with our long question, but same process for each question. We are giving you 20 minutes to stop video and then try. Okay, in this long question, initially they are asking you paradise law. All right. Please write it down and then I will show answer and then you can check, you can mark your answer. Yes, time's up, but if you need extra time, of course, you can stop and then stop video and then you can try. All right, Faraday's law. What is Faraday's law? Let's see. Oh, full definition is here. Please check with your answer. In exam, they're asking you exactly the same thing. All right, you cannot write in with your words. You must just write exactly the same thing. This is our just you can see two options for Faraday's law. All right. So in this topic, we have Faraday's law definition, and what else we have? Magnetic field, they can ask you, or magnetic flux. They can ask you three definitions. In this topic, we should memorize them all. All right. You can go to our another video to show all definitions. And if you are okay, we can continue with next question. Faraday's law, please write it down if you are having wrong answer. Just try to memorize it. For this kind of questions, nothing to do. We should memorize, we should learn. All right, now let's see another question in another 20 seconds. All right, time's up. If you need more time for this one, I think you don't need extra time, just 20 seconds, more than enough. So asking you two options to increase, what's that, reading on galvanometer. It means to increase current. What can we do for this solenoid? All right, that's our question. What we can do, guys? First of all, you can increase number of turns, or you can just move quickly, but they give only quickly inside the coil, or use stronger magnet. Or another option, you can increase number of turns. Increasing number of turns to get more current, or using stronger magnets, it's another option, or move magnets quickly inside the coil. Magnet will quickly go and come back. So three options we have. They ask you only two. So this is our answer for question 2.2. All right. From now, calculations questions coming. Make these questions coming. I hope you have formula box. If you don't have, please get it from past papers. Or I can just put it here formula first. Okay, let me give that formula, but formula box. Okay, let me give it to you. All right, formula box given. You are gonna choose from here. Just make sure which one you are gonna use. So calculate magnetic flux. All right, our time is over because some learners, they don't want to try, just they want to see answer. Because of that, only 20 seconds we are giving you just to stop the video. But if you try, it's gonna be much better for you. All right, so let's continue. We are gonna calculate magnetic flux. Let's see what is given. Area is given. And then what else given? Magnetic field is given 0.4 Tesla. You know, magnetic field unit is Tesla. And then we are looking for magnetic flux. So what about angle? Angle is 0 degrees. So with the perpendicular, it is 0 degrees. And let's see our answer now. Flux equals B times A times cos angle. All right. So what is B? B is magnetic field. Before answering question, maybe you can write all givens like this with symbols. What we have, B equals 0.4 Tesla. And then area equals 0.6 meter square. And then what else we have? Angle. Angle equals 0 degrees. If you write all givens like this, it will be easy to substitute all answers in the formula. So B is 0.4 and area is 0.6 and cos 0 degrees. And then you are getting your flux 0.24 WB. This is our unit for flux. So WB we are using, or Tesla times meter square. All right. So this is our magnetic flux calculation. I hope everything is fine. In this topic, they're asking you these calculations. Okay, let's continue with next question. I think this is the last one. Now, they're asking you, calculate the number of turns in the coil. Something is given, area is given, magnetic field is given, but now they change area from 0.6 meters square to 0.3 meters square. So if I said I'm not reading questions. All right, okay, just we explain. So you are going to calculate number of turns. Good luck. Our time's up. So what we are going to do, we are going to calculate the number of turns. Our formula, other we give formula, but we forget to give formula in the slide, but it's fine. But please get your formula box. Oops, sorry. Just get your formula box and then use it. All right, so from any past paper you can get it, formula box, or next time I can just give at the corner our formula. All right, so now we are calculating number of turns. First of all, we are choosing this formula, EMF equals negative n. What is n? Number of turns. Number of turns times change in flux over delta t. And you are getting what is change in flux? Final flux minus initial flux. What they said, initial flux we know already. Initial flux we calculate in question 2.3. What was it? Initial flux is equal to B times A times cos angle, and then B it was 0.4, A is 0.6, and then we calculate 0.24 WB. And then we are calculating our flux one more time because you change area. Okay, so B is still same, 0.4, A is 0.3, cos angle still 0 degrees. And then you are getting 0.12 WB, and you are writing your formula now. EMF is equal to negative n times final flux minus initial flux over delta t. And then EMF is 9. It is given in question. Number of turns we are looking for. And 0.12 minus 0.24 over 120. Why we are writing 120? Because time is, they said in 2 minutes. We know 2 minutes is equal to 120 seconds. We must convert to seconds always. Okay, if you use this calculation, you are getting your answer 9,000 turns. All right, number of turns, 9,000. It is positive because you're getting negative here, 0.12 minus 0.24, you're getting negative 0.12, and negative making positive, and then you are getting 9,000 turns. I hope everything is clear. In electromagnetism, what we have three definitions: magnetic field, magnetic flux, Faraday's law. All right, we have three definitions, and then calculations. They can ask you calculate to flux. You are using flux is equal to B times A times cos alpha, cos angle. And then B is magnetic field, A is area, and then angle you are getting from questions. Perpendicular, you are using 0. Parallel to surface, you are using 90 degrees. Why? Because we are using angle between the normal and magnetic field lines. What was the normal? Let's remember that. If you have a surface like this, you have a surface like this, and then this is your normal perpendicular to surface. If it is coming perpendicular, your magnetic field also coming perpendicular, it means it is parallel to normal. Parallel to normal means angle is 0. All right, perpendicular angle you are using 0. Sometimes angle will be given, but sometimes they said perpendicular. If it is perpendicular, 0. If it is parallel to surface like this, if magnetic field parallel to surface, it means perpendicular to normal. The angle will be 90 degrees, and cos 90 is 0, so you are going to get 0 flux. All right, but our formula is BA cos angle. And then sometimes with these questions, sometimes they are going to ask you calculate EMF. Number of turns will be given, but they change something. You know, for flux, maybe they change magnetic field, maybe they change area, maybe they change angle, maybe all of them they are going to change. And then you are getting new flux. When you get new flux, final flux minus initial flux, you are getting delta flux. All right. After that, you are going to calculate. For this question, they ask you number of turns. Next time, they are going to ask you EMF. Maybe next time, they are going to ask you time. Other things will be given. All right. So we have these two formula, three definitions and two formula in these topics. This formula box will be given, of course. Only we should know what is flux symbol, what is magnetic field symbol, area, symbol, angle, all of them. If you know those things, it will be easy. I hope this video will help for your exams. Good luck. See you next lesson. Something reminder. Thank you very much. Thanks for watching. See you next time.